The vast majority of modern scientific evidence contradicts the idea that the moon was placed or is an artificial object, strongly supporting a natural formation event known as the giant impact hypothesis. However, the idea of the moon being a placed or hollow satellite comes from a few observations that were once considered anomalies under older theories of lunar formation, which are often cited by proponents of the spaceship moon or hollow moon conspiracy theories. Arguments for a placed moon conspiracy theories. These are the primary pieces of information, largely from the Apollo era, that proponents of the spaceship moon hypothesis, first proposed by Soviet scientists Vasin and Sherbakov in 1970, used to suggest an artificial origin. 1. The ringing like a bell phenomenon. The claim: during the Apollo 12 mission, the lunar module ascent stage was deliberately crashed into the moon's surface. Seismometers left behind recorded the resulting vibrations, which lasted for nearly an hour. NASA scientists famously described the moon as ringing like a bell, suggesting it must be hollow or have a metallic shell like a bell. The scientific rebuttal. Modern science attributes the long-lasting vibrations to the moon's extremely dry, fractured, and rigid rock structure. Unlike Earth, which has water and different layers that dampen seismic waves quickly, the moon's dry environment allows vibrations to travel and persist much longer, like a tuning fork. Lunar seismology has confirmed the moon has a solid, differentiated interior with a crust, mantle, and a dense, though small, iron core. 2. The moon's low density. The claim: the moon's average density, 3.3 g cm3, is significantly less than the Earth's, 5.5 g cm3. This difference is cited as evidence that the moon is mostly an empty shell built by an advanced civilization. The scientific rebuttal. The low density is strong evidence supporting the giant impact hypothesis. The moon is believed to have formed primarily from the material ejected from the mantles, outer layers, of the proto-Earth and the impactor, which are less dense than the heavy iron cores. The heavy iron core of the impactor is theorized to have sunk into and merged with the Earth's core, leaving the moon iron deficient and therefore less dense. 3. The perfect solar eclipse. The claim: it's too great a coincidence that the moon is 400 times smaller than the sun, but also 400 times closer to Earth, making their apparent sizes an almost perfect match during a total solar eclipse. Proponents argue this improbable alignment suggests the moon was deliberately placed in that specific orbit. The scientific rebuttal: this is a geological coincidence that is temporary. The moon is gradually moving farther from Earth, 3.8 cm per year. This perfect alignment has only existed for a fraction of the Earth-Moon system's history and will end in the future, when only annular eclipses will be visible. Overwhelming scientific evidence for a natural origin. All physical evidence gathered from the Apollo missions and later research points to the giant impact hypothesis as the most accurate model for the moon's formation. Observation: isotope ratios. Evidence supporting natural formation. Lunar rocks have nearly identical oxygen, chromium, and titanium isotope ratios to Earth's mantle, indicating a common origin from a heavily mixed high-energy event. Volatile depletion. The moon is highly depleted in volatile elements, like water, sodium, and zinc compared to Earth. This is consistent with a formation event involving immense heat that would have vaporized and expelled these lighter materials into space. Small iron core. The moon's core is proportionally much smaller than the core of Earth and other terrestrial planets. This matches the prediction that the impacting body's core merged with Earth's, leaving the moon to form mainly from the lighter, iron-poor mantle debris. The scientific consensus is that the moon is a natural satellite formed from a cataclysmic collision early in the solar system's history, not an artificial construct. The moon isn't just a celestial orb. It's a gravitational anchor that dictates the rhythm of our planet in 3 mind-bending ways, affecting both water and time itself. The bizarre double high tide. Tides are the most visible effect, but the way they work is counterintuitive. The moon's gravity creates a bulge of water on the side of Earth closest to it, as the water is pulled directly toward the moon. This is the simple high tide. The bizarre part is the second high tide on the side of Earth farthest from the moon. This happens because the moon's gravity pulls the solid Earth itself away from the water on the far side, effectively leaving that water behind. The result is two simultaneous high tide bulges on opposite sides of the planet, and Earth rotates through these water footballs to give us two high and two low tides every day. The slowing of time, tidal breaking. The daily sloshing of the oceans has a powerful long-term effect on the rotation of our entire planet. As the Earth spins, it tries to drag the two tidal bulges with it, moving them slightly ahead of the moon's direct line of pull. The moon's gravity then tugs backward on these bulges, which acts like a constant infinitesimal brake on Earth's rotation. This process is called tidal braking, and it's slowly increasing the length of our day by about 2.3 milliseconds every century. The day was once only about 5 hours long. This stolen rotational energy doesn't disappear. It's transferred to the moon's orbit, causing the moon to drift about 3.8 centimeters farther away from Earth each year. The stabilizer of climate. Perhaps the most profound effect of the moon is its role as Earth's gravitational training wheel. Without a large moon, a planet's axial tilt, the 23.5-degree angle that gives us seasons, can wobble wildly over millions of years. For example, Mars's axial tilt is known to have varied from 0 degree to 60 degrees because it lacks a massive stabilizing moon. Our moon's enormous size acts as a gravitational anchor, keeping Earth's tilt relatively stable. This stability ensured that our climate wasn't subject to catastrophic, rapid shifts between extremes, which was pivotal for the long, uninterrupted evolution of complex life. The Earth's axis tilt is kept stable by the moon's gravitational pull, which is vital for maintaining our seasons and stable climate. Check out this video to learn more about the moon's influence on us. The moon's influence on us.